Hello, Mr. Bainey here. Let's practice solving some more systems of equations through word problems. Systems of equations, remember, are when we have two equations and they have two variables representing two different things. The challenge here is taking a word problem, something in context, and then translating that into our system to make up the two equations. And from there, you're going to be using the methods of solving systems that you've already learned, such as substitution. Let's go ahead and take a look at number one. At a college bookstore, a student bought a math textbook and a novel for $54. The math book is $6 more than 3 times the price of the novel. How much are each book? The question, how much, refers to the value of it, how much dollars. So that's going to help us with identifying our variables. This is the very first step. You can't write an equation if you don't know what the variables represent. So in all of these, we're going to use x and y. If you want to use different variables, just go right ahead because here we have two different types of books, a math book and a novel. So you could use m and n instead of x and y. But we'll go ahead and stick with just using this. X is going to represent the price. I'm just going to use a dollar sign here of the math book. And y is going to represent the price of the other book, of the other type of book, novel. Or price, not price novel, price of a novel. Okay, so again, you can identify these through just reading that question and understanding it. From here, we're going to build our equations. Our first equation is a student bought a math textbook, that implies one math textbook, and a novel for $54. So that means if we take X is the price of a math book and Y is the price of a novel, and you add those two prices together, then it costs $54. So X plus Y equals 54. That's the first one. Second equation is the math book is usually means equals. So the math book, we're going to use X because that represents the price of the math book, equals 6 more than, that means plus 6. 6 more than 3 times the price of the novel. So 3 times the price of the novel. Price of the novel is Y, so 3 times Y. And this here is our system. So I'll underline the sentence that came up with that second one. There we go. And from here you can use substitution because we have X is equal to this thing right here. If you're unsure of how to solve substitution, there is another lesson video that takes you through that process. So I won't be explaining it too much here. But since X is equal to that thing, we substitute this thing we circled, 4X, into the other equation. There's X right here. So instead of X plus Y, X will be this thing right here, plus Y equals 54. So let's write that over to the other side here. X plus, and I messed up already, so remember instead of X, we're writing that thing, 3Y plus 6, and then I do plus Y equals 54. So remember that this thing right here, the 3Y plus 6, replace the X that was there instead of X plus Y equals 54. So from here we can go through and solve this. I can combine 3Y and 1Y, that'll make 4Y. Then we still have plus 6 and we still have equals 54. Then we can go ahead and subtract 6 on both sides. And we get 4Y equals 48. And if we divide by 4, Y is 12. So this actually means that the novel is $12 each. If we plug that into this first, or the second equation, excuse me, Instead of x equals 3 times y plus 6, it's going to be 3 times 12 plus 6. So let's show that. 3, or x equals 3 times 12 plus 6. 3 times 12 is 36, and if we add 6, that'll give us 42, it looks like. So here's our answer. $42 for the math textbook and $12 for the novel. And just to confirm, remember that the student bought a math textbook and a novel for $54. So if the math textbook costs this much and a novel costs this much, they both do add up to $54. Okay, so you can double check to make sure that it makes sense. If you read that problem again, compare that to your answer. Number 2. Marcos had 15 coins in nickels and quarters. He has 3 more quarters than nickels. How many nickels and quarters did he have? Again, looking at the question, how many nickels and quarters did he have? We have 2 different types of coins, and how many means just the number of. So X we're going to use as the number of nickels. Y is the number of quarters. It's very easy but lazy to just say X equals nickels and Y equals quarters. But if you identify specifically it's how many nickels there are or number of nickels, I think that's going to help you with understanding this a little bit better. Now let's build our equations. First of all, Marco had 15 coins total. We don't know how many nickels and quarters, but if we add the number of nickels and the number of quarters together, that's X and Y, that will equal 15. This next one's a little bit trickier. He has 3 more quarters than nickels. So here I'm going to put my nickels right here on this side and then my quarters over here on this side. If he has 3 more quarters than nickels, then the quarters, the amount of quarters is a bigger number. So then we actually have to do X plus 3. Okay, see if this, let's make sure this makes sense. So whatever Y is, whatever X is, whatever number of nickels it is, if you add 3 to it, that's going to equal how many quarters there are, which means there's more quarters. So there's 3 more of the quarters compared to nickels. Okay, so it's very easy to mix that one up because I could have easily put X equals Y plus 3, which would be wrong because that means there's going to be more nickels in that case. Okay, here we have a Y equals this thing right here. Using substitution again, we're going to substitute this thing for the Y since it's equal to Y. We look for the Y in the other equation. So instead of X plus Y, it's X plus this thing right here. So I'm not going to go through and solve this whole thing, but I'll just start it off for you. So instead of X plus Y, it's X plus that thing I circled, and that's going to equal 15. Then you can go through and solve it. You're going to eventually end up, if you solve it correctly, with X equals 6. And that's how many nickels, remember. And if you think about it, that means there's, what, 30 cents? Okay, thinking about that might help you with some of these problems. And if there's 6 nickels, that means there are going to be 9 quarters. So if we compare this answer to our statements up here, there's 15 total coins. 6 plus 9 is 15, so there's 15 total coins there. And is there 3 more quarters than nickels? Yeah, there's a 3 coin difference between both of those. Let me write this so it's more accurate here. Our answer is 6 nickels and 9 quarters. As you go through these problems, here's my suggestion. Go through, read the problems. First, identify what your X and Y represent. Remember that it's going to come from the question that's being asked. Be as specific as you can get. That's going to help you build your equations. From there, after you build your equations, you can go ahead and try to solve it. But I would stick with just coming up with the X and Y, what they represent, identify the variables, then write your two equations. If you can at least do that for all the problems. And by the way, problems 9, 10, 11, and 12 are challenge problems for using substitution. We would actually use a different method, but I don't want you to worry about that yet. Go ahead and just come up with the equations for 9 through 12 and know what your variables represent. And you're going to be well on your way. There's not going to take much more to solve it. If you'd like to see the rest of the solutions, or at least the variables identified, so the X and the Y, and then the two equations, I'm going to be writing those in a handful of seconds. So you can pause it for now, or you can stop the video and then play it at a later time so that you can check your answers. I'm not going to write the actual solutions, the answers to the questions. Remember just what X and Y are, and then the two equations. Hey, thank you so much for watching. Have a great day.